initially we have not any cavity, let us consider. But if there is a cavity over here, then what will happen? This cavity portion, let us consider that this cavity portion has got a radius A. Then this cavity portion was supposed to contain a charge which is of value 4/3 pi a cubed rho. But this is basically a blank portion. So what will happen to this? Suppose we are given a charge capital Q over here. We know that this Q is rho into 4/3 pi capital R cubed, because capital R is the radius of the body, spherical body, and this is the cavity portion. Now, for a time's sake, hypothetically consider that this cavity is taken outside with this amount of charge, that is the Q dashed amount of charge. Let us consider this Q dashed amount of charge we are taking outside. So this body is being made with Q minus Q dash charge. It will lose Q dash charge, but truly it is given Q amount of charge. So there is no charge over here. So basically this cavity portion includes no charge. If we consider that Q dash portion of charge, we may think of in a different way, that there will be this Q dash amount of or quantity of charge which is as a whole neutral portion. No charge, because this is a blank space, so this can be thought of that this is neutral. See, there is no resultant charge over here or some kind of charge over here. So we can consider this cavity is taken outside, no charge is here. Virtually we are considering that it should have contained Q dash charge. So similar Q dash charge we thought of, that plus and minus, they make it neutral and no charge over there, as it should be. So if this Q dash is added over here, that is Q minus Q dash plus Q dash, which is already given as Q charge, then what will happen? This positive charge, if we superimpose this sphere once again on the cavity, then this Q dashed amount of charge will come to this body, and what will happen? The cavity will contain this negative amount of this charge, this negative amount of the same Q dashed amount of charge over here. No positive charge over here will come. So what we get whenever there is a cavity within a non-conductor body, what will happen? The cavity will constitute a negative charge quantity of value. What should be the positive charge it should contain if there would have been no cavity? कोई cavity नहीं होने से यहाँ जितना charge होना था पॉजिटिव चार्ज, उतना ही नेगेटिव चार्ज यहाँ कॉन्स्टिट्यूटेड होगा, क्योंकि ये जो पॉजिटिव चार्ज यहाँ था वो सरफेस में चला जाएगा विद इन द कैविटी सरफेस, एंड हियर देयर विल बी नेगेटिव चार्जेस प्रोड्यूस्ड बिकॉज दिस क्यू विल रिमेन ए कांस्टेंट. सो यहाँ का जो डेंसिटी, वो डेंसिटी सेम ही होगा लेकिन नेगेटिव चार्ज डेंसिटी होगा, क्योंकि यहाँ there will be negative charges spreaded all over this cavity. This portion will contain only the negative charge density, but the charge density will be negative of value, but magnitude is just reversed. Here it is plus rho, here it is minus rho. So net charge will be within this as a negative charge, which will be Q dashed, but this Q dashed will be minus 4/3 pi a cubed rho. So whenever within a non-conductor body we get a cavity, what will happen? The cavity will contain negative charge density, but the value of this negative charge density will be the same as the positive charge density spreaded over all the body outside the cavity. यहां जो चार्ज आएगा वो चार्ज, जितना चार्ज यहां पॉजिटिव रहना चाहिए था कैविटी नहीं होने से, उतना ही चार्ज, नेगेटिव चार्ज इस कैविटी में स्प्रेडेड होगा यूनिफॉर्मली. दैट इज द ओनली इंपॉर्टेंट कॉन्सेप्ट इन दिस कैविटी प्रॉब्लम. इफ यू जस्ट कंसीव दिस, देयर इज नथिंग. बाकी एकदम सिंपल चीज है. जस्ट let us get into something more on this, that what will be the property of such a cavity and how the electric field will be constituted. Electric field कैसा होगा within the cavity, बाहर, cavity के बाहर, और field lines भी कैसा होगा. Let us draw that diagram once again. Suppose that is the same body whose radius is capital R, let's say capital R, charge given is capital Q. I am not drawing the charges to make it simple. This is positive charge density rho. If we just constitute or think of a cavity over here as we have drawn for, then this is the cavity portion, and let us go for nomenclaturing its center, that be C, its radius be A, and here it is the center of the body be O. Then here the charge density is minus rho, charge amount is Q dashed, here it is Q. Now we will go for some position vectors. Let us define those position vectors properly. The center of the cavity with respect to the center of the body be vector R. Let us choose any point within cavity first. Cavity के अंदर एक point, let us consider that point be P point. So with respect to center, the position vector of this P point be R2 vector, and the position vector of P with respect to center of the cavity be R1 vector. Then by triangle of addition, what do we get? Vector R plus R1 is vector R2. So let us write that vector R2 is vector R plus vector R1, or vector R is R2 minus R1. Okay. So position vector of P, that will be R2 minus R1, that is R2 is position of P with respect to center of the body, and R1 is position of P with respect to center of the cavity. Okay. Now what will be the field at the point P? See, field at the point P, for both these it is inside point, for the cavity also it is inside point. Here the density is minus rho and it is at a distance R1. So due to this cavity, let's say this cavity will produce a field here. What it will produce? EC will be minus rho R1 divided by 3 epsilon naught. Just moments back we discussed that what will be the field within a solid sphere made out of non-conductor. Then the field at this point is minus rho R1 by 3 epsilon naught. Negative, because this is negative charge density. Then with respect to the positive charge density or the total body, let's say that be EO. This is also vector. Then it will be what? This is positive rho R2, because with respect to center its position is R2. So rho R2 by 3 epsilon naught. So what is the resultant field at this point? These are the two things. There is no other thing. So resultant field at the point P will be EO plus EC. Then EO is how much? Rho R2 by 3 epsilon naught. This is minus rho R1 by 3 epsilon naught. Then EP is, the field over there is rho into R2 minus R1 divided by 3 epsilon naught. That gives rho R by 3 epsilon naught. A very, very interesting result. Let us write it over here once again. So field will be within the cavity, it is rho vector R divided by 3 epsilon naught. Rho is a constant, 3 epsilon naught universal constant. You see that vector R is also a constant. Why? Because center of the cavity and center of the body, they are fixed positions. So this vector is a constant vector. This is vector R. This is a constant vector. So at any point within the cavity, field is a constant field. Not only that, it is directed along the direction of the vector R. You see that this field at any point is directed along the direction of this vector R. That means it is parallel to this vector R, or it will form field lines which is parallel to the R vector. That means the direction of the field lines will be like this. Since positive charge density is here, so it is along this direction, and a cavity thus produces uniform electric field within the cavity. A cavity produces uniform electric field within the cavity. Magnitude is how much? Rho R by 3 epsilon naught, and direction parallel to the direction of the vector R. What is vector R? Vector R is the constant vector, that is the vector in between the two centers, the center of the body and the center of the cavity. Now, if we want to find field within the body where the cavity is there, let's see what will happen then. Let us go for that discussion. Let us draw the body once again. This is our body, and let us draw the cavity now. The cavity is here, another spherical cavity. Now what will happen? What do we want to know? Let us draw this centers. Center of the body is here, that is C. Center of the cavity is here. Center of the body, let us make it O, that is done earlier. This be C, and this is the position vector of the center of the cavity with respect to the center of the body. Okay, that is our old vector R. In case of within the field, we have seen the field is uniform and directed parallel to the direction of R. But now we want to find the field at any point within the body. Let's say this be S. Then again we will draw the position vectors. This is our R2 vector with respect to center of the body, and this is our R1 vector with respect to the center of the cavity. Then what will happen? Same relation, vector R is R2 minus R1. But let us go for the charge distribution pattern. This is plus rho and this is minus rho. So with respect to plus rho, this is again within the body. So what will happen? The field due to this positive charge density EO, that will be again rho R2 divided by 3 epsilon naught, as it should be, because it is within the body. Now what will be due to this cavity? You see that due to cavity it is outside. Outside means what? Outside means we know 1 upon 4 pi epsilon naught, the charge amount q prime, because here the charge is q prime, divided by the distance r1 square. If we go for vector representation, then what will happen? 1 upon 4 pi epsilon naught, this is q prime, divided by r1 cubed into r1 vector. This will be along r1 vector, but just note down here that q prime should be again replaced in terms of volume density. So what will be q prime? Q prime will be minus rho into 4/3 pi a cubed, because a is the radius of the cavity that we have taken. So if we replace this, then what will happen? Just replace it here. Only thing, it will come as negative. So 1 upon 4 pi epsilon naught, q prime is minus already we have written, rho into 4/3 pi a cubed divided by r1 cubed into r1 vector. Then 4 pi cancelled out, we get minus, we are getting minus rho, then this is a cubed divided by 3 r1 cubed into r1 vector. Since it is negative, then this field is in the reverse direction, as it should be, because here it is negative charge cluster. This cavity has got negative charge cluster, so field will be in this direction for the cavity. Then what we get? This is minus rho a cubed by 3 r1 cubed, sorry, there is, I missed 1 epsilon naught, here it is. So r1 cubed epsilon naught into r1 vector. So what will be the resultant field at S? So ES is nothing but EO plus EC. Then if we add these two, then you see that rho by 3 epsilon naught, we can take again common, rho by 3 epsilon naught. Then what remains? Here it is r2 vector minus a cube by r1 cubed into r1 vector. That is the field within the body but outside cavity. That is the field expression. You can see that if we want to find field at origin, we will just make r2 vector as the null vector. Then what will happen? E at O, for this, due to this cavity, we can understand this will be along this direction, because r2 is 0, r1 becomes r. So what we get? This is minus rho a cubed by 3 epsilon naught r1 cubed into r1 vector. That is the field at the center of the body. So now we know that due to a cavity, what happens? Before getting into a typical problem that I will discuss with you, but what we know now about electrical cavity. Just let us sum it up very quickly. Within a conductor body, a cavity does not comprise anything. No